Okay, you ready? This is going to drive me a little crazy in part because if the board were up here, I'd be happier. So glycine, alanine, valine, leucine, methionine, isoleucine. That one, I'm underlining it because it's one of two, arguably four, that are different from the amino acid name that they are derived from. But these are the three-letter abbreviations. Proline, serine, I don't know if I'm going to have room. Threonine, cysteine. So there's cysteine, cysteine, and cysteine. One of those cysteines is the Sistine Chapel, or something like that. One of them is cysteine with an, I think it's EI, which is what we're talking about here. And then there's cysteine with just an I, which is a disulfide linkage. But just giving you a little heads up that cysteine. Am I going down? I am going down. Cysteine, and then asparagine. I'm going to underline that too, but that one's almost the same. Glutamine, GLN. Come on, Steve, you can do this. Lysine, try to go up a little bit more. Arginine, histidine, phenylalanine. Boy, we'll fit. Tyrosine, and tryptophan. And tryptophan is another one that the initial letters of the three-letter codes are not simple. The three-letter code is not simply the first three letters of the name of the amino acid. Okay, so all amino acids have an alpha carbon. I'll draw it over here. Can everybody see this? Okay, so they'll have an alpha carbon, and they'll have an NH2 and a COOH. It's really poorly drawn. Let me do a better job. There we go. COH. And of course, that proton tends to be lost. And this tends to gain a proton. So at neutral pHs, it's actually going to be NH3 plus and COO minus down here. But that's an amino acid. There's going to be a hydrogen here, and then there's going to be an R group. There's one exception to that in terms of the structure, and that's proline. Okay, so just drawing the R groups. So the R group of glycine, glycine's the easiest. The R group is just H. Alanine is CH3, okay? These, in fact, are the I'm dreading this, that I'm going to spell it wrong, but I think it's a pH. The aliphatic amino acids. And so alanine is the simplest of the aliphatic amino acids. Valine has a V. Isn't that convenient? Leucine is alanine, alanine plus valine. So it's got a C there, and then it's got that. Methionine, this one you just kind of have to remember. Looks like that. So it's 4 units plus various hydrogens. Carbon, carbon, sulfur, carbon. That's the first amino acid you typically see in a peptide, and when it's being translated. Isoleucine, instead of having the extra carbon there, you have it there. Proline, so proline's the weird one. Let's skip over it and come back to it. Serine, so these are all of the polar not charged. Amino acids. So serine is essentially alanine with an OH group on it. Threonine is like serine, except there's also a methyl group that comes off there. I think that's right. I think I'm drawing it correctly, but I have doubts in my mind. This is one of the ones that drives me a little crazy. But it's basically, I believe, serine with a methyl group coming off of it. Cysteine is serine, but instead of the O, there's an S. These are the way I've got this memorized, and that document, which I can show you, is I put down all of these ideas of how to do this memorization. Of course, how you do your memorization is up to you. The way I do it does not necessarily work for everybody, or really anybody except me, right? Asparagine goes C, and then it has an amide group on it. I think it's 2 C's and not 1 C. I might be wrong about this. I know that there's... We're going to go over that and come back to it if I'm wrong. But basically, glutamine is the same thing, except that there's an additional C. So we'll just draw it like that, and we'll come back to it and fix it if I'm wrong. Lysine. So lysine. I've done something wrong. I've forgotten 2 amino acids. Asparagine, these are the 2 negatively charged amino acids. Glue. I didn't put glue? No, that's gly.
Oh.
That's okay. So asparagine, so these are the negatively charged acidic amino acids. I've clearly forgotten that. And the same problem is there for these. I'm forgetting how many carbons should be there. But they're the same structure, except that rather than being an amide, it ends with a carboxylic acid group. The way I'm screwing up is I'm asking myself, is that carbon one of the carbons I was counting? Or was I counting 1, 2, and then it? So we're going to come back to that. We'll do a little erasing. So that's glycine and glutamate or glutamic acid and aspartate or aspartic acid. So those are the acidic, negatively charged amino acids at neutral pHs. So now lysine. So these guys are the positively charged. So they're the bases. Those are the acids, these are the bases. So lysine, so I told you a little while back that the way I remember lysine is that it goes 1, 2, that's a Y, 1, 2, 3, 4, and then the N. 1, 2, 3, 4, and then the N. And because it's positively charged, it's going to be an NH3 plus. And then arginine, ARG, the abbreviation is ARG, that's 3 letters, right? Now I know they're all 3 letters, I get it. But whatever, this works for me. So therefore with arginine it goes 1, 2, 3, and then it's just like awful. It's N, C, N, double bond, N, with 2 H's around it, making that positive. That would be NH2. That needs 3 bonds there. That's got 4 bonds. So that's arginine. Arginine is just weird, but I remember there are 3 carbons because ARG. Histidine. Histidine, you have alanine, and then you have a 5-member ring that happens to be the same as the ring that you see in the purines, the 5-member ring in the purines. And that one, because of resonance, so there would be an H there, but there wouldn't be an H there, but the resonance structure would be the H there instead. And so it would have these partials, and then the H's would be, I don't know how here. But in any case, as a As a consequence of that resonance structure being more stable than this structure, it wants to acquire another H, and hence it's a base. So that's also positively charged. Phenylalanine is alanine plus a phenyl group. Tyrosine, so it's tyrosine, tyrosine. There's an O there. So it's C with the phenyl group with an OH on the end. And then tryptophan, you want to kind of shoot yourself. So I'm going to do it in the other direction because that's, so this is starting with the alpha carbon up here. So there is a C there. And then it is a 5-member ring. And then it is basically a benzene ring. And I'm going to draw it like that and that and that. And I think that's an N. Let me check on those two.